Hello friends, welcome to the today's video. We are going to discuss about today we are going to discuss about support vector machine. So this is like this is an example for classification. So for classification we are going to use this method. So support vector machine. So we are going to see in detail that this is a powerful classifier and it is also a parametric classifier. Parametric means based on changing the parameter, the classification accuracy is going to be improved. So this one and linear regression, Navier Bayes. So these are all the parametric classification. So before jumping to this today's session, let me just walk through with yesterday's or a previous sessions. So we have been just seeing what is the linear regression, what is the equation for it, how exactly it is going to work. So how to draw a straight line for a data by using a equation of y is equal to mx plus c. M means slope, c means intercept. So the general form of intercept for straight line is given by x by a plus y by b is equal to 1. So by using all these things, we have been just rectified a difference between or classified between two classes for linear data, and we have been just seen the bias functions. First one is polynomial bias and Gaussian biases. So due to this biases, it is going to enhance the overfitting into the respective model. So whenever the overfitting is going to happen, that is like fitting the curve as per the data. So whenever the data changes of two classes, you are going to fit as per the respective data. So polynomial and Gaussian. So these are the two versions we have been just seen, and we have been just seen how to classify the non-linear data as well. So in a non-linear data, it is just like it is not separable by straight line. So during that cases, we have been using this non-linear predicting information by using this polynomial features with a linear regression. So later we have been just seen the prediction of a bicycle traffic during the times. So it can be daytime, it can be dry day, it can be a rainy day. So how to convert a temperature, or what is this, the values into a temperature. So these are all the things, and we have been just fetched the holiday calendar of other countries. You can just fetch our countries as well. So let me just show that how to fetch the holidays in an later sessions of our respective country. So after this, we have been just predicted how exactly the model have been just provided with the errors. So as simple as it, we have been used a linear regression, and we have been trained it, and we have been predicted it. So this is the simple. If you are understanding the sample coding here, so this is a sample coding, just having a x and y. The same has been used here, but for x and y we are pushing the data set. So that's the funda behind it. So let's dive into the today's session. So we can just go here. So this is an example for classification, as I told you earlier. So this is a example for classifications. So SVM is abbreviated as support vector machine. So what is the support, what is this vectors, and how this machine is going to call? Let's see this in the next slides of this respective video. So SVM, support vector machines. So it is a powerful flexible classification algorithm used for both classification and regression methods. So it works very well for classification, and regression also it is going to just provide a greater results of 70% around. So with SVM we can achieve maximum of 85% of accuracy. So this is called as an accuracy method. Okay. So powerful actually means that it is able to differentiate the two classes into with a definite boundaries by using a hyperplanes. So in linear regression we are just drawing just a line, but whereas here we are going to draw a hyperplanes. We will just see what is this hyperplanes, how it is going to differ from straight line differentiation. So one thing you need to understand here, it is a powerful. Using hyperplane you can just differentiate the things. So how it is flexible? So flexible means you can just vary the parameter and it is adjustable to the new data. So it has been applicable for classification and regression. So from scratch we are going to build a SVM for classification problem. So classification problem means, so if you are going to have, you need to differentiate between a circles and a rectangle. If it is a linear data, you can just have a hyperplanes. So and you can just make a classification. So we have learned a simple model describing the distribution of each underlying classes. So here distribution actually means that, so distribution means we have been just seeing the Gaussian distribution or Navier Bayes based on the probability we are going to be just distributed. So that is what we have been just seen till now. Based on the classes we have been distributed, and they have been used to generate a generative models for probabilistic determining the labels. So based on the classes they have been just provided some of a probability of occurrence of a labels for the new points. So that was an example for generative classification. So we have been seeing Navier Bayes, linear. So this is a generative models based on the classes. They are going, based on the classes means based on the features, they are going to provide some of a probability of occurrence of a labels. So it has been just connected to one side of a classes, something like this. So descriptive classification is our SVM. Instead of modeling for each class, we are using lines, bar, curves. So lines, it is not a straight line, it will be having some margin. So let me just discuss what is this margin, how to generate a margin, and what is this hyperplane actually means. That hyperplane means it is a differentiating line between two points. So we are just going for a simple code here. So creating the two separate classes by considering the 4 point. First we can just create a sample coding here. Okay, let me take so to effective utilization of a time, I have been just typed the codes earlier. I will just copy and paste here to maintain the time. Why? Because this theory part is too much high. You need to correlate between theory and coding. Then only you will understand what is machine learning. Simply by coding you cannot understand what actually it is going. You may feel that it is just a points and all. So if you are knowing the knowledge of a theory part, how to get a points, how to make a difference and all, then it is going to make a difference. So I am just naming the file as SVM. So first I am going to import some of our packages which we are going to just use here. So okay, SciPy is already installed. So then use the Seaborn plotting defaults. So we are using this. So we are importing this Seaborn. So it is having some of the packages, it is having some of the functions, and cns.set actually means that we are setting the path for this respective current directory. So next we are generating a example, like simple points we are going to generate. So for generating we are just using this simple points. So we are taking a data set. So sklearn, we are just importing make blobs. Make blobs means some random points clusters will be generated. See, blobs means we are having 50 points. In this 50 points, it has been divided into two centers. So random statements, you are going to change these points every time. So cluster standard deviation is 0.60. So in two centers, your samples are going to be distributed. And you are going to just plot that scattered with x values. So 0th column, first column. So you will be having the all this respective C mapping. So S and C. So C is a parameter what we are going to just see in our respective SVM. So we can just see this what does this C actually means. So it is like a parameter which is going to vary the respective lines. So you are having two parameters. So you can execute this. I've been just forgotten to write this show, that's why the figure has been not displayed. So not displayed means it will be displaying and closing automatically. It will be not available for us to see. So this is a data points what I have been just speaking with. So these are all the data points which have been scattered with the two centers. This is one center and this is one other center. It has been scattered all around. So you are going to see this data, and this is linearly separable data. So by just drawing one line, we can separate these two data points. Now we are going to have a see like it is not easy, like it may look like a easy task. We can draw by hand itself. See, like if I am just taking this lines, so the task can be done by using the hand itself, or whenever we are going to use a hand, it may seem that it is a too much easy task. But coming to a practical session, so instead of drawing a single line, we can, there is a axis of drawing more than one lines. Okay, let me just erase this. So all these three lines are considerably distinguishing the points. So all these three. So now the task is like how we are going to select the better line. So that is which is going to make a accurate classification between two classes. So this is class 1 and this is class 2. So all these three lines can make a effective decision. See, like it can divide between two classes, but whenever coming for an accuracy, these three lines will give a different accuracies. So this may give some accuracy, this may give some accuracy, this may give another accuracy. So now your task or a system task or our task is to find which line is going to be just an accurate one. So first we are going to generate these three lines. So you can just see the points here. Okay, we can have the points here. So one is at a first point. So first point, x-axis is 1 and it is extending till what is this, 0.64. So this is 1 point and it has been extending till this value. So this is another point. So starting from 0.5 to 0.5 to 1.6. So this is a first point. In the same manner, you will be having first and 0.65. So 1.6. So this value. So like this, by seeing the coordinates, we can draw the respective lines. So that's what we are just doing in this respective equations. So we are just manually drawing. So xfit is equal to np dot line space minus 1 comma 3.5. So line space means this value. So starting from minus 1 to 3.5. So this is a dimension or a maximum limit, minus 1 to 3.5. So for this, again we are just plotting the scatter. So scatter the same values x, we are accessing only the columns. So the same thing what we have been just done here. So you can just copy and paste this. And you can just plot this. So this is what we have been just done. Let me just explain after just having a copy of this. So we have been just made a dynamic limit ranging from minus 1 to 3.5. We have been accessing, this is the same thing. What we are plotting here is plot 0.6, 2.1 on x-axis. So it should be in red color. So marker width is 2 and marker size is 10. So what I am doing here is I am just taking a new data. So the job is mark this 0.6. So 0.6 will come somewhere here, 0.6 and 2.1. So at some point here there is a new data. Let me take a new color. So it is not resembling to any of our classes. It is a new data. So this new data should be just pushed to the any of this classes. So push it to any of these classes, class 1 or class 2. So whenever like this of data is coming into picture, you need to select a optimum line to make a differentiation between class 1 and class 2. So this is what we are going to just do it. So for this data, we need to generate a lines. So let me see. So let me show you what is this respective lines are going to just do it. So after a line generation, so you are having the lines you need to just cope up with. So this is a manual lines. So you are having M, B in these values 1, 0.65. So 0.5, 1.6 minus 0.2, 2.9. So you can just see here, these are all the respective lines which have been just provided here. What is the x-axis value and what is the y-axis value. So x-axis, y-axis you can just see here. So starting from this value, you will be starting y-axis. So like this, you are just generating a 3 respective lines. So after generating a 3 lines, you have been plotting for each values of B. So 3 values. So x fit value. So for this value we are fitting, what you are fitting, M into x fit plus B. So this is a respective equation for SVM, and it is having some color modification. And I am limiting the x limit, the dynamic range is minus 1 to 3.5. Why? Because this I have been taken the fitting value ranging in that value. So X limit means above or below you will be not getting any values. So above this or below this there will be no values, you will be having that limit. So in this range only you will be drawing the newer values. So this is like now you are having a difficult task. So now you have been just provided with, there is a new data called X. Our task is to make this new data to any of our labels. So it is not easy as it is. So all these three lines will eventually discriminate these two data. But coming to this new data, so for making this to one class or class 1 or class 2, it is not as easy as we are saying. So we need to go in a deeper version, like how to generate a hyperplanes. See, like if you are selecting one of a line, you need to have some margin for it. So margin means if this is a boundary, there will be some precaution warning. So that in that range, so that will be a respective differentiating line. So let me just show you this, how to generate a margins. So why we need margins is, so why we need the margin values is like, so whenever, just for an explanation sake, I am just taking this line as my hyperplane. So by taking this line as a hyperplane, so this line eventually cuts all the data. So whenever we are getting a new data, so we need to have some margin to make a effective decision. So if you are taking this one also, it will be generating some margin, but it may give a wronger results. So how to generate a margin is like, so this, if you are selecting this line, okay, where is a mouse? So if you are selecting this line, the margin should be taken such a way that it should reach the nearest value. So nearest data set feature. So this is a nearest data set from this line, and for this point like this. So this is a margin if you are choosing the middle value, and this will become a support vectors. So which are all sitting on a margin will become a support vectors. Why we are using the support vectors is, so now the new data has been just accumulated here. So it is inside the margin. So whenever it is inside the margin, we are going to count a number of support vectors. So how many is giving support to the class 1 and how many is giving to the class 2. This is going to happen only when the crucial decision is going to happen. If the data is here, it is going to tell that it is class 1. If the data is here, it is going to tell that this point is belonging to class 2. If data is here, then it need to count the number of support vectors here, and it is saying that this new data belong to here. Why? Because the support vectors for class 1 are lesser. So now we are going to generate a margin here, and this is a very complex thing you need to understand. To differentiate between the data, we need hyperplanes. So choosing the one line among the three, so all the three will serve the purpose, but choosing the optimum one is a task now. So that is what we are going to do here. So instead of having a zero width, we are going to enhance the width of our line to make optimal decisions. So XFIT we are having, we are plotting this data again. So we are taking this data, okay, you can just have all these things. So let me give a margin full. So now I am going to talk about margin. So I am taking a line space, I am drawing it, I am having 3 lines here. So all these 3 lines have been plotted. and we are going to fill between the x fit and y fit. What we are filling? Minus d plus d, minus d and plus d. For executing this, let me tell the equations for hyperplane, or else it will be just confusing. So this is a hyperplane you are going to generate for a data. So this is a optimum hyperplane, H0, H1 and H2. These are the three hyperplanes we are going to just generate with. So these are all the data, red and green. So how these hyperplanes have been generated? By using this equation. So w into x plus b is equal to plus 1. So, and another equation is w into x plus b is equal to minus 1. So this is a margin, and this is another hyperplane, w into x plus b is equal to 0. How this middle one is going to be just generated is after having these two labels. So this plus 1 indicates for class 1, minus 1 indicates for class 2nd. So we are going to take a median of these two classes and we are going to draw this hyperplane, or by having an equation of w into x plus b is equal to 0. By changing the various inputs and with the same weights, we are going to enhance or draw this hyperplanes. So how it is generated? W into x plus b will be greater than or equal to plus 1 when output is, or a label is, plus 1. So when hyperplane wx plus b will be less than or equal to minus 1 when y will be equal to minus 1. So hyperplane h1 and h2 are hyperplanes here. So it is w into x1 xi. So xi means I can be 1, 2, 3. xi plus b is equal to plus 1. So these are all the respective equation. W2 that is hyperplane 2 is given by w into xi plus b is equal to minus 1. So h0 is a median value where w into x plus b will be equal to 0, where x is an input vector, b is a bias, w is a weight vector. So this is weight vector w, b means bias value. So the bias value will be given by the user. So it will be always will be equal to one value, like 1, 0. So x is a input vector, b is a bias and w is a weight vector. So now we are going to maximize the margin. So this is our margin. So this is our hyperplane. So we are going to maximize it by distance d. So how to maximize the margin? So margin to the line, instead of a line, add some width till it touches the nearest data feature. So this is what I am telling. So I am taking this hyperplane. Why? Because it is farther to both the data set. See, like if you are choosing this hyperplane, if the new data is being just available here, so it is belonging to the class 2. But due to the selection of hyperplane here, so it will make a wrong selection as it is belonging to the class 1. So if the point has been just provided here, so if you are choosing this hyperplane and if the new point is available here, so it belongs to the class 1. But due to this hyperplane selection, it will say that it is belonging to the class 2. So this is a wrong decision. So this is what it is going to happen. In order to avoid this, we are choosing a hyperplane which is far away from all the data points. So we are choosing this line and we are extending this width till it reaches the nearest data point. So here we are having 6 support vectors which is touching the width of a hyperplane. So what we are doing is we are selecting one line. That line should be far from both the data set, and we are increasing the margin. Instead of a single line, we are increasing the margin. So whenever the new data is coming here, so it is going to count the number of support vectors here. So here for the support vectors we are having 2, hence it is going to give a decisions for class 1. So like this. So if we are having a new data, so if you are having a new data here, so again we are going to find the support vectors for this. So the support vectors are saying that this data is being just need to be pushed for class 2. So like this. So that's why we are going to maximize the margin. Instead of a line, we are just taking some considerations. So why this consideration is needed is, if the data, new data being came at other points here, other than a hyperplane, if the new data is available here, it will just easily say that it is class 1. If it is here, it will easily say that it is class 2. When the decision will become crucial is when it is falling on the hyperplanes. So to make an effective decision, we need to maximize the margin, and we are going to call it as a, what is this, support vectors. So we can just see this. In order to do that, we need a parameters, that is C and S. So we have been just done here. So now we have been plotting this, and we are just waiting for the plot to be just shown. Oh sorry, it is PLT. So now we can just see the 3 lines. So this is a data we have been already seen. So this is a margin what we are just seeing with. So this is a newer data. We can just save this. And we can take this to our respective working. Okay, now for all this lines, it has been generating a margin here. So you can just see here, if you are choosing this line and this line, what are all the effects? So apparently this one is belonging to this line or this classes. So if you are choosing this hyperplane, it may give a wrong decision saying that it is belonging to the class 2. So if you are choosing this line, so if you are choosing this line, so it may give that sustainable results, it is belonging to the class 1. So the optimum is this line, so it is having some margin, so now it is belonging to the class 1. So if you are having a new data here, it will say that it belonging to the class 2. So now it is belonging to the class 1. So this is a effective utilization of a margin, and this is going to happen in turn in an sklearn. So this is a building from scratch. So this is a line, differentiating line. So this is an optimum line we are choosing. For this, this is a margin which have been provided by a distance d. So that have been done in your coding part. So you have been just seen here, distance d plus distance d minus distance d. So these are all the values which have been given for the margin. So plus d minus d. So we will be getting 2 margins, plus d minus d. So that is what here. So we can just show here. So this is plus d and this is minus d. So that's it. So now we have been created a margin. So after creating a margin, you need to train a data. So how the training is going to happen? Again, you need to use the fitting. So this is a equation or procedure for training any of a data. So when you need to train any of a data, the command is fit. So from sklearn you are importing SVC. support vector classification. As I told you earlier, it will work well for both regression and classification. SVR means support vector regression, SVC means classification. And I am kernel, I am going for linear kernel. Why? Because this differentiating line is straight line. Here also we are having non-linear, we can just see in the latest session. So what I am doing, I am just fitting the model. So here we are having this parameter called C. So it has been used, we are going to take it as a large number. So why we are keeping this parameter to large is, we can just see in an eventual thing, you are going to understand. If a parameter is high, you will be having more flexibility. So now you are going to fit this respective model. So now this is a data. So this is a margin. Now the system is trained. Now I need to see the results for the new data. So for visualizing the results, so there is one of a program here, so which is going to make a effective decisions. Okay, I will just explain this, what actually it means. So now I have been just written one of a function called plot SVC decision function. What it is taking, trained model, and you need to plot a support vectors, and AX is none. So it is not used here, it is a parameter which have been not used. So AX is none, and we are going to use this AX is equal to plot GCA. So these are all the limit values, X limit, Y limit. So what is a dynamic limit where points need to be plotted? So we are taking X value, Y value, and we are having based on the limits, and we are generating some points. So now we are going to have model decision function X comma Y, and we are going to push the decision to P. So after this P, we are going to just plot the decisions. So we are taking support vectors, we are plotting support vectors, and finally we are setting the limits. So decision is made, we are taking the support vectors also, and we are just plotting it. Let me show the support vectors here. So I am just scattering X and Y with the C and Y S parameter. We are just plotting this. So this is data, this is a hyperplane. Okay, we need a plt.show. Okay, every time I'm going to forget this. Data, hyperplanes have been generated with margin for new data classification. So this is where the support vectors are being generated. You can just see here. So this is a part where you are going to just see the support vectors. So you can just take here figure, where it went. Have it not saved or what? Let me save it again. Desktop. It has been saved to other folder, I guess. Okay, desktop and figure 3. So now we have been enhanced the margin. I am choosing this line. So we are just enhancing this margin to plus the and minus the to the nearest point. So this margin should be extended to the nearest point. So these points have been touched. So these are going to be called it as an support vectors, and this is going to make a helpful during when taking a crucial decisions. So this attribute is going to be called it as support vectors. We can just see this, how the support vectors are going to be just printed. We can just see model dot support vectors, and we can just print it. So what are all the values which are being just generated, we are going to just print. So this is a data, so this is a margin. I am choosing this one now. So this one have been chosen, and these are the support vectors, and it has been returned here. I will just printing this support vectors. These are all the support vectors in X and Y directions. So this was all about how to generate a support vectors from scratch. So like this line, see like here we have been generated a respective line. This doesn't change the accuracy of working if this training points have been doubled. So now considering we are having only 50 points. So if we have been increased it to 100 also, this line will not change. So this is the beauty of a support vector machines. If you increase from 50 to 1000 also, this line will make it work properly, or it is going to provide you a accurate decision. So this is where the the support vectors are going to play a important role. So this is all the support vectors. So let me just show you how exactly the things which are going to just not change whenever we are just having the points rising from 50 to 120. So here just changing the samples, I am increasing the samples to 200, and centers are same and deviation are same. We are using the same kernel, we are using the same version. We can just see the support vectors, and the line is going to serve the better thing if we are increasing the data samples as well. So this is for previous data. So now you can just see, so these are all the training data, 60 samples and 110 samples, sorry 120 samples. So here we have chosen this line as a support vector. It has been maximized with its own decision. It is perfectly working fine. See here by enhancing the 120 level, we are having the same lines here. So this line is considerably providing a effective decision. So this line is not going to just change if we are changing the number of training values from. If we are changing the samples also, the model will not change. So that is what the beauty of a SVM, where you are going to just see with. So if we are changing the data points also, the model will not change. It remains same. So this is the beauty of the tool. So we have been just seen the margin of a lines can be enhanced to the nearest data feature. So the line which is maximum width is selected as description line between two classes. See, like this line they are just speaking here. So this line is a one which is the maximum distance from both the data points, that will be selected. So example for maximum margin, and we have been just seen the fitting of an SVM. So the SVM has been fitted using the, what is this, scikit-learn, using linear kernel, and we are choosing C parameter as very large value. So for seeing the support vectors, the code we have been just seen. By varying the training points, that is from n is equal to 60 to n is equal to 120, it doesn't make any changes. So that is what we have been just seen here. Okay, and we have been just seen the code for it as well, and that was a thing we have been just seen. So we are changing from 60 to 120. There is no change in the model. So that have been generated by your PyCharm. So next we are going to see about non-linear kernel. So whenever the data is linearly separable, we can separate by drawing a straight line or hyperplane, by generating a hyperplane. So it is not just a straight line. Now if the data is non-linear, if it is not a linear one, then we are having two options. If data is not separated by a straight line, if data is not performed by a linear line, we are having two ways. Increase the data dimension to, if the dimension is n, increase the dimension to n plus 1. If the dimension is 2, increase it to 3. This is the first option. Second one is use the kernel function based on the data set. So we are having a kernel function called RBF. So RBF actually means that radial Bayesian function. So if your data is non-linear in nature, let me just erase this. So I am just speaking about radial Bayesian function. So if your data is non-linear, see like this. So this is a data. This is a class 2. So this is class 1. This is class 2. So now what this RBF is going to do is, it is going to find a exact circumference of a class. So how it is going to find a circumference is, it is going to find a variance. So how the variance is going to be find it off? So you need to find the circumference of this point like a cone. So it will be in the shape of a cone. So now from the top, so the cone will be like this. From the top, you need to find the center. Oh, sorry, the line have been just changed. So from the top, you need to find the center point O. And this point O, if you are getting a O, we are going to find a radius of this extending A, and we are going to draw a radius. So that will be a circumference of a class 2. So after finding the circumference, you can just find the distance of a classes here. So what is the distance? So you are going to find the distance based on the distance. If the distance is less, you can tell that it is a class 2. If the new point, based on the circumference, by comparing the distance with the circumference, then you can decide the respective, what is this, whether it has been belonging to the class 1 or class 2. So this will be the circumference and this will be the new point. It is going to find the distance between new point and the circumference. It will be nearer. So if it is far here, then it is going to say that it is for class 1. If it is distances nearer to the circumference, then it is class 2. These points. So this is called as an radial Bashial function, RBF. We can just see that how to code it for non-linear data, but the funda is too much simple. You need to find a variance of this point. You need to find a center value and you need to draw a radius that will become a circumference. Which are all the new point coming with the nearer circumference. So then that point will be considering to the class 2. If the newer point is here, it is going to find the distance to the circumference and it is going to say that it is class 1. So now this is class 2. So this is like what is non-linear data, and you are having two ways. One way was to use a non-linear kernel, that is RBF in SVM. Another way is to convert this linear data, that is 2D to 3D, that is from dimension n to n plus 1. So if you are converting it, it will be just converted into this format. So after conversion, you can use linear separation as previous one, what you have been just seen, and you can make a classification. So now we can just see what is this, how to create a data, like how to create a data, how to convert a, what is this, how to increase the dimensions and all. It is very interesting and it is very convincing too. So first we are going to create a data here. So how to create a data, we can just see is it is working fine. Okay, first we are going to create a non-linear data. Okay, creating a non-linear data. Okay, x and y, we can just go for this. So this is like how to create a non-linear data. So here we have been just made a circles, the factor of 0.1, and it is having some of a noises. So it is going to just create a circles from sample generator which have been available in a data set. Okay, coding we can just see. In the coding part, it is clear that these data cannot be divided by linear regression. Okay, we can just plot the data here. Plot a data and you are just making it as to show. So this is a linear separable data which have been seen earlier, margin and support vectors. So here comes, whenever we are changing a training set, the model doesn't change if we are increasing the training data set. So this is where our data is there. So this is circular data. So this is class 1 and this is class 2. So you can just go for this. You can just save it in a desktop. So you can just have a name here and you can just paste it in the respective files. So here you are just seeing this. So it is clear that you cannot make a difference using this linear separation. These are the hyperplanes. You cannot separate the data considerably using a linear regression. So think that how to make this to project in the third dimensions. So now you are going for a first option. So the ways is like increasing the data to the third dimension. So let me just see that how to do this. So by projecting this data. So solution to the problem. Increase the dimensions. But how to increase the dimension here? So dimension actually means that the way of allocation of a points. So this is a 2D. You are going to enhance it to a 3D version. So now you need to increase the dimension. So considering these are all the points. So let me just have a graph here how to show you. So these are all the points. The steps is like make x minus 8 in an, what is this? In an signal and systems, you will be seeing about shifting a data. So if it is minus, you are going to shift towards right side. So you are going to shift towards the what is this left side of a signal x minus 8. Later you are going to square it. So now you are going to create a, what is this, x values. So x values here. So you need a graph here. So okay, insert a chart. Can go for line chart. And in line chart we need a values like 2, 4, 6, 8, 10, 12, 14. So okay, we can just create this. We need only a one category. So 2, 4, 6, 8, 10, 12, 14. So these are all the series you have been used with. Okay, we can try a scattered one. Okay, x value, y value. Okay, we need only x value here. So x value is 2, y value is 0. 2, 4, 6, 8, 10, 12, 14. For all this we are just making x value as 0.